I am Professor J. N. Mandal, Department of Civil Engineering, IIT Bombay. You know how to perform the tensile strength of the geosynthetics material. Different types of the geosynthetic material have their different type of strength. It may be open geotextile material, it may be non-open geotextile material, it may be geogrid, it may be geomembrane or geosynthetics clay liner. So, from the tensile strength of the geotextile, we will calculate the different types of the property. Here I am showing that method of determining the tensile modulus of geosynthetics material. You can draw a relationship between the stress, that is F by L in the x axis, y axis, and the strain this is L by L in the x axis. So, this nature of the curve, let us say stress strain curve of geosynthetic material is like this. So, these are the stress strain curve. Okay. So, from this stress strain curve we want to determine that what will be the initial tangent modulus. So, if we can draw a straight line from the origin tangent to this circle, and the slope of this will give you that what is modulus. Modulus. So, from this you can calculate the initial tangent modulus. So, you can determine the initial tangent modulus. So, slope of the curve will give you the initial tangent modulus, and this initial tangent modulus will be very much useful for any numerical analysis. Similarly, we will determine the offset tangent modulus. So, different types of the geosynthetic material, they give the different types of stress strain curve. So, suppose this is the strain and this is the stress, that is F by L. So, you can have the sum of the curve of the geosynthetic material is like this. Is like this. So, this is the nature of the curve of a geosynthetic material. So, from this nature of the curve you can determine offset tangent modulus. Yes. So, what you have to do to how to determine the offset modulus. So, you can take a tangent through this here. So, this is the slope. So, this will give you the what you call stress strain curve, and this is the offset. So, this part is the offset, this is the offset, and this is the modulus. That is A by L. So, you can determine the offset tangent modulus of a geosynthetic material. So, this is the stress strain curve, this is the offset. So, you can take the slope which will give you that modulus, that is called the offset tangent modulus. Now, you can have the other type of the property which you call the second modulus at a desired strain. So, if you draw the stress strain curve of geosynthetic material, for example, this is the strain, this L by L, and these are the stress, that is A by L. So, you can have the sometimes that stress strain curve, let us say like this, like this. So, this will give you that what is the stress strain curve, stress strain curve. So, you can determine from this stress strain curve what should be the second modulus at desired strain. So, you can determine the second modulus. Second modulus at desired strain. And this value is very important for the design of any kind of the geosynthetics reinforced soil related structure. For example, if you want to construct a reinforced pavement, then you need that what would be the second modulus and the corresponding strain value. So, for any strain value, if you take this value and then for a particular strain, so it is the strain, for a particular strain you can draw a line, okay, you can draw a line. So, which will give you the modulus, that is F by L. For any desired strain, that means this slope will give you that second modulus. If this is the peak value, you can take half of the peak value with corresponding strain, or 1/3 to 2/3 with the corresponding maximum value, or you can decide any strain value, and then you will be knowing that what will be the slope of this line, and which will give you the second modulus of the geosynthetic material. I will give you one example how to determine all the modulus value. So, as I said, for different geosynthetic material, it may be non-woven, it may be heat bonded, it may be needle punched material, and they have their different thickness. So, properties of the different geosynthetic material will be the different. For an example, that we are considering a non-woven geotextile material. Okay. So, let us say this is the non-woven geotextile material whose tensile stress and strain curve looks like this. And this material have some thickness, and this material have some mass per unit area. For example, this material is non-woven heat bonded material, and mass per unit area of this material is 135 gram per meter square, and thickness of this non-woven heat bonded geotextile material is 0.33 millimeter. So, for the non-woven geotextile material, as it is shown the tensile stress versus strain relationship curve, and from this curve we want to determine that what should be the strain, what should be the elongation, what should be the toughness, and the modulus in this geotextile material. So, first of all, from this stress-strain relationship curve, we want to determine what should be the strain value. So, here you see that maximum this strain value, tensile stress value is about, you can say this is about 23 kilonewton per meter. So, you can write that strength, that means maximum strength, that is T of maximum is equal to 23 kilonewton per meter. And we know the thickness of non-woven heat bonded non-woven heat bonded geotextile material, thickness is about 0.33, this is millimeter. And also mass per unit area is 135 gram per meter square. So, we have to determine that what should be the maximum stress. So, sigma of maximum will be equal to 23, this divided by the thickness is 0.33. So, this will give the value of maximum stress is 69,700 I think kilonewton per meter square. Or you can write this will be 69,700 kilopascal. So, what is the elongation or maximum strain value? So, if you can look here, maximum this is the strain. So, maximum strain value is somewhere here. So, this is let us say 50. So, this is about epsilon f is about 69 percentage. So, this is 69 percentage. So, strain value, let us say maximum strain is equal to 69 percentage. So, you can write epsilon f as a maximum strain is equal to 69 percentage. So, you know that maximum strain, you have to determine toughness of geotextile material, toughness. Toughness is designated as U. Okay. So, this U will be equal to half of T of maximum into epsilon f. Earlier we determined T max, which is 23 kilonewton per meter. This is T max, it is 23 kilonewton per meter. So, we can write this is equal to half into 23, and this is the maximum strain epsilon f, and epsilon f maximum strain is 69 percentage. So, you can write this is 69 percentage. Okay. So, if you calculate the toughness, also you can designate it as E of G, toughness is equal to is about 7.9 kilonewton per meter. So, we know that thickness of the geotextile material is 0.33. So, we can write that toughness also in terms of kilonewton per meter square for the thickness of 0.33, that means U can be determined as 7.9 this divided by thickness is 0.33 is equal to 24,000 kilonewton per meter, or you can write 24,000 kilopascal. Now, we have to determine that what should be the modulus, that means what should be the initial tangent modulus, which is initial slope. So, from this tensile stress strain curve of the geotextile material, you can determine what is modulus. So, you can draw the tangent like this. This is the tangent, and from this tangent you can determine what should be the slope. For example, that let us say that this for the 10% strain value and the corresponding the strain value 10, or you can say that let us say for the 12% strain, for the 12% let us say strain, this is stress value 12% stress, and the corresponding strain value let us say about let us say like this actually. So, this is the stress value, this is the strain value, let us say strain value is about 10%. So, what I am trying to say, if the from this curve, if I take that stress value is about 12 kilonewton per meter and corresponding strain value is equal to 10%. So, modulus of geotextile material will be equal to 12 divided by 0.10. So, this will give you 120 kilonewton per meter. So, from this curve basically I am writing that if this value is the 12, this value is the 12 and corresponding the strain value let us say it is 10. So, that is why the stress value is 12 kilonewton per meter, strain value is 10%, then modulus will be 12 by 10 is 120 kilonewton per meter. Now, you know that thickness is 0.33 Therefore, E can determine, or this is you can say modulus as a E can be determined as 120 kilonewton per meter. This divided by thickness is 0.33. So, this will give you 364,000. This is kilonewton per meter square, or you can write 364,000. This is kilopascal, or you can write 364 megapascal. Okay. So, from the stress strain curve of the geotextile, you can determine different properties of the geosynthetic material, that is initial tangent modulus, second modulus, and that what should be the defined types of the modulus or offset modulus, etc. Now, I will give another example for a non-woven needle punch geotextile material. For example, this is the tensile stress and strain curve for the non-woven needle punch geotextile material. This is non-woven needle punch geotextile material. And this material, I say that it is non-woven needle punch geotextile material. And this geotextile material, let us say mass per unit area is equal to 200 gram per meter square, and thickness is equal to 0.63 millimeter. So, from this curve of the needle punch non-woven geotextile material, you have to calculate that what would be the initial tangent modulus, what should be the offset tangent modulus and second modulus as 10% and 35% of strain in kilonewton per meter and kilonewton per meter square or kilopascal, based on the initial thickness of the geotextile material is 0.63. So, first of all, that what should be the initial tangent modulus. So, initial tangent modulus that is designated at E of t. Let us say that this is the initial tangent modulus, and for example that this from here, this is the initial tangent modulus. Okay. And let us say for the 50% strain value, 50% strain value, that corresponding that stress, let us say 4.3. So, what will be the modulus value, initial tangent modulus value? That means 4.3 by 50%. That means 4.3 divided by 0.50. So, this will give you 8.6 kilonewton per meter, or if you want to determine in terms of kilonewton per meter square, then you know that what will be the thickness, and then you can determine in terms of the kilonewton per meter square, and that will be about 13,600. This is kilonewton per meter square. And the next is that what will be the offset tangent modulus. So, offset tangent modulus is offset, remember this offset tangent modulus, which is designated at EOT, offset tangent modulus. So, offset tangent modulus is, if I draw a offset tangent modulus. So, for example, that when the tensile stress is about 20 and the corresponding the strain value will be, let us say here is 46 and here it is 10. So, this is the 20, this is 46 and this is the 20 and this value is about 20 kilonewton per meter, and this is the strain. This is the offset modulus value, slope of this curve. So, offset modulus EOT will be equal to 20 divided by 0.46 minus 0.20. So, as I said that this is 20 and this is 46 and 46.20. So, you can have the offset tangent modulus value is about 77 kilonewton per meter, or you know the thickness. So, you can determine this as 122, 123 kilonewton per meter square. And you have to calculate the second modulus at 10%. Let us say second modulus at 10% is ES10. So, ES10. So, you can calculate the second modulus ES 10%. That means, if you take for the 10% you have to determine. So, this is the 10% and correspondingly value, let us say 1.1. So, ES 10 you can write 1.1 divided by 0.10 is equal to 11 kilonewton per meter, or you know the thickness. So, you can determine that in kilonewton per meter square, 17,500 kilonewton per meter square. Similarly, for the 35% strain, let us say this is the 50, let us say this is the 35 here. So, for the 35% and the stress value is, let us say 11.6 kilonewton per meter. So, for the 35% strain you can write ES 35 is equal to 11.6 divided by 0.35, because this is the 35 here, this is 35 here, and this is corresponding stress value 11.6 and 35.33. This will be 33 kilonewton per meter, or you can say 52,600 kilonewton per meter square. So, from the stress strain curve you can determine the initial tangent modulus, second modulus or strain at any stress at any strain value, modulus at any strain value. It may be 10%, 35%, 20%, etc. Thank you.